We see the equal sign here, right? So that means we're supposed to solve it for n is what they're asking us to do, right? When you see an equal sign, usually you're trying to solve something. But do you remember when you're solving something that you first have to simplify each side? Okay, so that's what we're going to have to do. So let's focus on the left-hand side there. If I'm going to simplify it, I'm still thinking, when I think of the word simplify, PEMDAS should pop in my head, right? Because when we simplify, that's kind of the rules that we use. So if you think about PEMDAS, it says to do parentheses first, but is there anything inside either of those parentheses that you can simplify at all? Nah, they're different terms, they're not alike, or they're subtracted from each other. Can't really do that. So the next thing is exponents, which we don't have any on the left side. And so now we're down to the multiply or divide. Is there some multiplying to do here? Yeah, the distributive property is just multiplying, isn't it? So if you look at this, let's do the first set here. We got to get this multiplied out. 2 times n is 2n. 2 times negative 3 is negative 6, right? Now it's all of that plus, yeah, I got some other stuff I got to multiply here. Isn't this another multiply thing here that I need to do before I start combining any terms? Okay, so PEMDAS says do that next. N times 2 is 2n again, right? We're just going to write it in that order. We always put the number in front of the letter. Positive n times a negative n. A positive times a negative is a negative, and n times n is n squared. It's like n1 times n1, add the exponent, it's n squared. Okay, let's keep working on this left-hand side. So this is just 2n minus 6 plus 2n minus n squared. Well, we can combine some stuff, couldn't we? We have a 2n and a 2n. What would that be? 4n. So we have 4n minus 6 minus n squared. Normally I would make y'all write that in with the n squared term first, but it has a negative out front, and we're going to move it anyway. In a minute we'll see. So let's just leave it that way for now. Sometimes leaving it's okay until the very end. Now, I know I got to solve for n, and it's a little scary when you start seeing n squared show up, because usually that means you're going to have to do some factoring, but we haven't got to that part of the book yet. So anytime they show up here, you're probably going to have them go away. Let's say I wanted to collect all the n squareds on one side for some reason. Let's say I wanted to move them to the right. I'm just going to say I'm going to pick some place. It doesn't matter, because watch what happens. If I wanted to move my n squareds all together, and I go, let me move them over to the right-hand side, I've got a minus n squared. Wouldn't the opposite be to add an n squared?
They would cancel out.
Yeah, they cancel out here, and just because I made them do it, but over here, look what happened. They add up to 0. So for a minute, you just might start sweating a little bit, thinking you're going to have to do something here that's harder than you really have to do. Things cancel out so far in the book when we see n squareds. So I have 4n minus 6 is equal to 2. What do you do now?
Add the 6 and add the 6 to the 2.
Yeah, both sides are as simple as they can be. So you're going to solve for n. So just move the, when we solve, we go backwards on PEMDAS. So we add or subtract first when we're solving. That would be 4n is equal to 8. So now what, divide by 4? And what's n going to be? 2. So they put a whole bunch of stuff together. And that's the thing. All these little pieces that we're doing get put together into bigger types of things, bigger contexts like this.
Can we do 19?
Sure. Okay. On 19, the instruction says simplify. How do I know I'm not going to solve it, even though the instructions didn't say solve? How else do I know I'm not going to solve this? What do you have to have in order to solve something? Equal sign. So we can't even solve it, right? So we know all we're doing is just trying to basically kind of get some terms together. And so when we see that word simplify, what are we supposed to remember that we're supposed to do or think? Yeah, we're adding like terms, but again, that comes down to PEMDAS, doesn't it? So simplify is, when you simplify, you're kind of thinking PEMDAS no matter how weird the stuff looks. So PEMDAS says do parentheses, but if I look in my parentheses, there's not really anything to do, is there? And there's not any exponents yet. There will be eventually, but it's not like, there's anything to do with them right now. So isn't the next step multiply, divide? And you go left to right. and I look and I see, anytime I see a distributing problem, I see a parentheses with something out front, that's a multiply thing, isn't it? Because distributing is just multiplying. I've actually got one there, and don't I have another one over here that I'm going to have to do? And then remember, adding would come after I multiply all that out. So that's kind of guiding our thinking here. All right, so here we go. We're going to distribute 2x times x is 2 times 2x squared. The 2 times the invisible 1 is 2. X times x is x squared. Remember, you can put the little ones on there, and remember the rule is to add the exponents. Now, 2x times negative 3. A positive times a negative is a negative, right? Now let's do the number part since we did the signs first. What's 2 times 3? 6. Oh, and there was an x to smush on it, right? Okay, now we got that little expression simplified. Let's go over to the right hand expression in the red. So we're just going to distribute there. What's x times 5? How would you say that? 5x, yeah, you can always just do that. And then a positive times a negative is a negative, and x times x is x squared. Okay? So now we don't have to solve anything here. We just have to collect like terms, right? So you got some x squared. You got 2x squared minus an x squared. Is that going to be 2? Is that what that is? 2x squared minus x squared is 2 because the x squared's canceled out, right?
Yeah. No.
I'm trying to trick you. No, I'm trying to do what I see a lot of students do on their work. What if I put a 1 out in front of that x squared? Do you remember that when you're doing like terms, you write the like term down, which is x squared, and you add or subtract the numbers out front, and I have a 2 and a minus 1. So 2 minus 1 is 1x squared. 2x squared minus x squared would just be 1x squared, which we write as x squared. Okay, I like to do this when I'm done with them so I can see what's left. So now I have a minus 6x here. Remember, we take the subtraction sign to be like a negative sign. A minus 6x and a plus 5x. I want to buy something that costs $6, but I only have $5 in my pocket. How much am I short? 1. So that's minus 1 because I'm $1 short of those x's. Again, I'm just writing the like term down, and negative 6 plus 5 is a negative 1, so I write that up front. But normally we would just write that as what, x squared minus x. Now, I'm going to point out something. Never mind, I'm not going to say that. Never mind. Okay, here we go. Now, PEMDAS, it simplifies, so I need to think PEMDAS, and maybe it helps me to write it out to the side, because when you get something this complicated, just having something that it's off your brain onto the paper is a good way to start. Remember, P stands for parentheses, but it also stands for any grouping symbol, doesn't it? Again, we said GEMDAS might be a better name for it. So, there's some grouping symbols in there. Did I copy that down right?
Yeah.
Okay. If you look in the grouping symbols, we've got these overall brackets here. That's a set of grouping symbols, isn't it? But then inside of there, you got another set of grouping symbols, and it says 5y minus 41. That just seems like a weird number. 4. Okay, that's what I was wondering if okay, so that's a 4. I must make a very thick bracket to cover that up, okay? So, inside that blue parentheses, that's the innermost parentheses. That's where we'd start, but there isn't really anything to simplify there, is there? So we can't really do anything there. So now I'm kind of looking at the red brackets, because that's my next grouping symbol. Oh, it is.
Oh.
It is, yeah. Sometimes it doesn't tickle. It's good. Yeah, it is. And sometimes it's hard to tell. Okay, so inside those red brackets, I got another now whole new grouping thing. That's like another whole PEMDAS problem. All of this is like a new PEMDAS problem I have to look at. So let me do this, just so I remind myself. I'm going to put my negative. I'll make my brackets red just so I can kind of tell where I'm at in the problem. And so inside of there, I've got 6y minus 3 times 5y minus 4. PEMDAS would tell me to do parentheses again, but we already said there wasn't anything to do there. There's no exponents. But isn't there some multiplying and dividing and multiplying to do, because don't you have some distributing to do in there? Here is what I would do. I would put my 6y down, and I would say, let's distribute this negative. I would take that as a negative 3, and I would distribute it over those two terms. A negative 3 times a 5y. A negative times a positive is a negative. 3 times 5 is 15, and there's a y that goes with it, right? Now, let me distribute that -3 times a -4. Remember, we're taking the signs, at the operation of the subtraction sign and looking at it as a negative sign. -3 times a -4. A negative times a negative is a positive, so let's put a plus down. And 3 times 4 is 12. Oh, it's not looking so bad now. It's just taking it one little bite at a time, right? Inside that red parentheses, you got 6y minus 15y. Those are like terms, aren't they? I have $6 in my pocket, and I want to buy something that costs $15. How much short am I? You're short like $9, right? Remember, this is combining like terms, so we write the y down and we say, oh, 6 minus 15 is -9. And then we got the plus 12. Okay, so now I have a negative in front of those brackets. What does a negative do to everything that comes after it? It switches the sign. So I could just say, hey, that negative outside is switching the signs on both the terms inside. That's one way to look at it. We'll do it that way first. A negative -9 would just be take that to -9 and switch it to the opposite sign. Wouldn't it be 9y? And I have a positive 12, but it's a negative 12, right? Negative positive 12 would be a negative 12. So you could just switch this sign here and this sign here, and you'd be done. Another way to look at it is this. If you don't like that way of thinking, or you don't see why it works, there's a negative out front, but we could always fill in with a 1. And you could distribute. -1 times a -9y would be a positive 9y. And a -1 times a positive 12 would be a negative 12. Are you starting to see why that you can just look at a negative out front as switching the signs on everything that comes inside? It disappears and it switches the signs on everything. And this is the reason why. This is the thinking behind it.
I kind of can't